Good afternoon, ladies and gentlemen. I hope you all are well. So, this afternoon, we have another two keynote talk. The first one is by Professor Liu Han from Tsinghua University, and another is Professor Chetan Singh Solanki from IIT Bombay. So, we'll start with the keynote talk from Professor Liu Han entitled Maritime Decarbonization to mitigate global climate change. So, unfortunately, Professor Liu Han cannot make it live, but she has prepared the recorded talk. So let me start by introducing Professor Liu Han. So Professor Liu is committed in working at the frontier of earth science, study on the interaction of human activity and atmosphere, which has led to her major contribution in coming up with new ideas of coupling traffic, material flow, and atmospheric system to improve the understanding and predictability of contemporary atmospheric environment. She worked on various topics, including the first theory and technology of dynamic traffic emission models for street, regional, and global scale. Second, a multi-scale air quality coupling model adaptable for complex urban underlying surface environment. And third, regional transportation emission model scheme and global emission reduction framework theory correlated to supply chain. So her research was funded by National Science Fund for excellent young scholars, and she also won numerous awards, including the Newton Advanced Fellowship, the Gold Award for Young Scientists of China, Environmental Science Society, the Top Young Talent of National Ecological and Environmental Protection, and the Chinese and Clean Air Award by the United Nations Environment Program. So let's welcome Professor Liu Han. So for the participant or audience,
is the Bible.
if you have any question after the talk, please type in the chat box. Okay. Then we'll pass to Professor Liu Han to respond to your question. Okay. Thank you.
Of the global economy. Thanks to this maritime transportation, we could purchase products all over the world. However, we've got a big problem on our hands with global warming. So today I'm going to talk about the shipping decarbonization from a research perspective. I'm Huan Liu from Tsinghua University. This slide shows that from the IPCC AR6 report, it reaffirms with high confidence that the AR5 finding that there is a near linear relationship between the cumulative anthropogenic CO2 emissions and the global warming. The cost. So each 1,000 gigaton CO2 is assessed to likely cost to 0.2 to 0.6 degrees Celsius increase in global surface temperature, with a best estimation of about 0.45. So this relationship implies that the every ton of the carbon dioxide emitted contributes to the global warming. And for shipping, shipping is responsible for the more than 80% of the world's trade by the volume. So most of the goods were transported by shipping, and the ships emitted billions of tons of the greenhouse gases per year. So due to our estimation, for every 10 seconds, it's about 300 tons of CO2 emissions from the global shipping. And if we compare the shipping sector with other countries, so it should be ranked here about equivalent to the sixth largest greenhouse gas emitter. So that we know that global shipping is a big issue for the global climate change. And on the other hand, for the air quality, so we compare this criteria pollutants with land-based emissions. So for the globally, the shipping NOx is about contributing to 16% of the total NOx emissions. And for this is for China coastal regions, so it's about 18%. So it's like that for the gaseous pollutants, like more than 10%. So for the fine particulates, it's almost 10%, and for primary particles, it's about 2%. However, the responsibility for the global shipping is hard to be defined. We have heard that a rule is called the polluter pay principle. However, with the offshoring separates the consumers from the producers, so it brings about pollutants emitted by the other countries, and then the rules can be changed into the beneficiary pay principles. So a lot of good studies are paying attention to quantify those treated embodied emissions. However, they pay more attention in the production end. The transportation is one of the role in the supply chain, and which was not well defined. So this also need to be understood to clarify the global trade flow related CO2 emissions. And this is not a new issue. Actually, scholarly and political dialogues for the past 3 decades, they focused on the UNFCCC-based approach to regulate the international shipping emissions. For this based approach, 8 options were compared, and finally, 5 options were recommended. So the first one is no allocation. So that means taking the shipping emissions as a whole, do not allocate it into countries, or allocate the ships transnational activity emissions to individual countries according to, for example, number 3 option, to based on the bunker fuel sales, or based on the 4 is company vessel registered or the operated, and the number 5 is a departure or destination for that vessel, or number 6 is based on cargo. However, researchers tried very hard to give the quantitative results for that, and right now there are studies to define for like option 3 and option 4, and we can find that very big difference based on different allocation options. And another issue is if all the emissions are only attributed to like ship owners or operators or the flag country, it would limit their further investment and development in trading. So we don't see enough push on solar option for that. So right now the UNFCCC is taking option 1, which is no allocation to use. So based on this allocation scheme, the problem is those related regulations was intentionally set outside the national allocation schemes in either Kyoto Protocol or the Paris Climate Agreement. So to this end, the IMO, which is the International Maritime Organization, they announced an initial strategy on reducing shipping greenhouse gases. So they set a very ambitious target, which is at least 50% of the total greenhouse gases will be cut by 2050. And they also provide a wide list of the candidate measures. However, these ambitious targets for the shipping emissions still call for new approaches to encourage decarbonization by different stakeholders. And we can see right now it's not very optimized because under the forecasting, if under 1.5 degrees scenario, about 60 to 220% of the allowable CO2 emissions. So that's the total emission we can have under this scenario are expected to be consumed by shipping. So that means just one sector, only shipping, would consume all we can have the CO2 emissions by 2050 if we cannot have a very effective measure on the emission control for that. And actually, shipping is one of the hardest sector to reduce its emissions. So this study find that among those 33 gigaton CO2 by the global fossil fuel and industry, there are 9 gigaton CO2s are very, very hard to be eliminated, and which include shipping, aviation, and long-distance road transport. So those are related to transportation sector. And the first step we have done is we built a model called the Shipping Emission Inventory Model, SEIM, SEIM. And this model compared with previous approach is we generated the methodology into the third generation. So it's based on the dynamic method. So here I want to show a little bit about the advantage of the approach. So the previously is more, we call it Euler model, because when the shipping sending out the AIS signals, which was captured by the satellite or land-based receptor, we have a lot of signals. And then the researchers can have different grades. And for each grade, we can accumulate the total signals inside of the grade and then make the allocation of the global total emissions into each grade. So then we get the high resolution of the emission inventory. However, if there are repeat of the signals, or there are some neglect of the signals, it will get overestimation or underestimation for the emissions. So it's not very accurate. And this problem is very significant in the Asian region, because the coastal line in Asia is very complex, and so it brings a lot of the error for the emission estimation. So our new approach is we based on the static database to first select all the signal from one vessel, and then generate the route for that vessel and calculate the emissions. So this trajectory-based interpolation method, which is the disaggregated dynamic approach. And based on this approach, we can calculate the global shipping emissions and give a relatively high resolution of the emission distribution. So this brings us some new knowledge. For example, we can see that in Asia region, which has the strongest signals. So that means the emission intensity here is the highest in the world. And we further use the climate and health model to calculate the climate and health impacts. And we found that the radiation forcing from the shipping emissions in East Asia was increased from by 20 times, but it's strong cooling effect, because this is for 2013, the target year. So the bunker fuel was used, and the sulfur 2 emissions will lead to the strong cooling effects in atmosphere. And on the other hand, the shipping emissions would lead to large adverse health impacts. So our estimation is it lead to 24,000 premature deaths in East Asia every year. And in this year, we updated our emission model SIM into the version 2. And the second version improves 3 modules. The first module is we have improvement of the reroute method. So that is to, for example, for ship, it has the signals here, point A, and another signal is when it's in the location B. And then using our trajectory generation approach, we will give it a line. In our previous model, obviously it's not correct. So right now we have big data, and we accumulated enough real shipping routes. So we generated another route approach, so we can get this route restorated by our approach. So we can have very clear estimation in the coastal regions, and also another benefit is that we get very good estimation for those inland rivers. And the second module is we now distinguish the ocean-going vessels and coastal vessels, and also river vessels, because they are using different fuel in China. So for the river vessels, they use very low sulfur fuel, only 10 ppm. But for ocean-going vessels, it is obey those IMO regulations. So then we can estimate the emissions and its policy impacts. So the third module is policy built modification. So we can have those estimation to respond to different policy to save the emission reduction effects. And now the same module can give us a global estimation for the shipping based on real time. And we have from 2016 to now, compared with the IMO greenhouse gas, you can see that our estimation is close to the IMO results. And in addition, we provide our collaborator with high resolution, that means the special resolution of high time resolution products. And then the next step is we based on our SIM model, which is to using the shipping activity to estimate emissions and understand the environmental impacts. The next step is we build a tree sim, which is linked with the driving force. So here we consider is trade or the material flow. And by introduce the trade here, we want to understand how the global material flow can influence the global shipping. And so here I give an example for the China and the US bilateral trade. So the first step is we identify bilateral voyage based on the AI-based big data. So we build a geographical fence for the China and for the United States, so we can identify how many signals are related to China and the US bilateral trade. And so based on this approach, we trace the shipping emissions about 4,000 vessel calls in 2016. So those are related to this bilateral trade. And then we found that shipping emissions embodied in China to US export are about 40% higher than that US to China exports. However, if we compare this to the trade surplus, which is 300, so the difference in emissions were rather small, that indicating higher CO2 emissions per value trade from the US export. And we trace the shipping emissions of those vessel calls back to the US-China bilateral trade of more than 12,000 subcategory products, cargoes. And we can say that with the trade-driven study, we can have new knowledge to understand which sector is contributing more to the emissions. For example, the US export is more on vegetable products, or the wood pulp paper, and other products. So those is the driven force. And also it bridges the gap in the transportation related emissions in supply chain for this bilateral trade. And we can say that using here is using sulfur dioxide as an example. And maritime transport could increase the traditional trade-related emissions with an increment about 20% in this US-China bilateral trade. And for if we pay attention to US export commodity, the emissions generated in the production activity can account for can only account for 41. This is in production end, and more than half of the emissions are from the transportation end. So this is why it's quite important to include the transportation-related emission into the supply chain analysis. And then using the chemical transport model, GeoScan, we further checked the global distributed impacts on the ambient PM 2.5 concentrations from the shipping related to this bilateral trade. And we found that the concentration increased by up to 1.13 microgram per cubic meter due to the shipping emissions. And not only in China was influenced, here we can see that South Korea and also the Japan, they were affected by this trade. So then we further have this health consequences evaluated based on the exposure level to PM 2.5. And we see that the US-China trade embodied in the shipping emissions can cause about 5,000 premature deaths. And most of them happen in China. And another issue is differ from the production end. You see, for production-related health consequences, it's mainly related to those two countries, so where the production activities happen. But for the transportation end, there are about 34% of the deaths occurred outside China and the US. So that makes the issue more complex, because if we want to have this responsibility allocated, then it's a problem. So here in this study, we generated this integrated trade to shipping to activity to air quality to health impacts nexus to allocate the impacts. And we found that if we choose greenhouse gas emissions or the trade value or the premature deaths as indicators, it will result to different allocation results. So that means that it's quite complex for the responsibility allocation, and further study is required. And then the next step is we want to expand our study based on those bilateral trade into the global scale. However, right now only few studies try to link the shipping emissions with trade, and those studies. This one is for our study. Another one is for the Brazil study. They highly based on the cargo data or the waybill data, but this data is not globally available. So there is still a technical challenge to make this trade link the shipping emissions for global perspective. And then we spent several years working on this. So finally, we built a voice and GTEMS model chain. And this model chain solved this problem for global scale. And this model includes two parts. The one part is the voicing model. The another part is the GTEMS model. So I will skip the technical details, but you will see there are many modules inside of this model. So it's based on our previous same model, tree-same model, and we add several new modules, so it can systematically investigate the international maritime trade linked to shipping emissions. And here we use 2018 as a target year, and we have built about 31 billion of AIS signals, and also a good static database to support this study. And then the results, this part is from the voicing result, the first model, voicing. So it can give us the international shipping CO2 emissions. And this is the graded emission for more than 800,000 individual OD, original and destination voyages from a specific country to another country. So this is what we observed from the shipping. So we calculated it into emissions. And this one is the EEOI based calculation. So this is not observed anymore, but this is based on the GTEMS. So this is from the trade data, from the economy data to calculate, to using this generated EEOI calculate the total emissions, and then we can see the efficiency and also the total amounts. So based on this approach, we can have this flows, the emission flow from one country to another. And we have thousands of those emission flows. And we found that top 10 high emission flows collectively contribute about 17% of the global shipping emissions. And also we can evaluate the weight-based or the value-based emission efficiency for the global shipping for each kind of the cargo export for each country pair. So it's a little bit complex to be introduced in short time here. And this is commodity-based estimation and the commodity based efficiency in for global wide. And we hope to use this approach as a baseline to find out a route for global shipping mitigation. And then we set up a scenario, which is an optimal scenario. That is, if the total import and export volume of each commodity is left unchanged, but the trading partners are optimized, then the global shipping CO2 emissions of the international trade commodity can ideally be reduced by 38%. So it's this figure. So it's equivalent to about 280 TG. So that shows a very big potential for the emission reduction. So we want to ask for this new framework for global shipping emission reduction. And it's coupling the technology and also the economy, considering both technical measures and also the trade optimization. And the voice MG times model train can serve as a backbone to support the evaluation. And finally, it helps to achieve the 50% reduction goal. So this is my presentation, and thank you very much. We were supported by several projects, and those are the related articles I've introduced. So I'm happy to discuss with you by emails. Here is my email. Thank you very much.
Thank you for the interesting talk from Professor Liu Han. So Professor Liu Han has left her email on the last presentation slide. So the participant who would like to communicate with her, please send your interest or question to her email. So without further delay, let us proceed to the next keynote talk by Professor Chetan Singh Solanki. Professor Chetan Singh Solanki would like to deliver an interesting talk entitled Energy, Climate, and I. So let me introduce Professor Chetan Singh Solanki, who is an educator, researcher, and innovator who is currently on unpaid leave from IIT Bombay. He has undertaken energy storage yantra from November 2020 through a solar barge for 11 years until 2030. In this yantra, Professor Solanki has pleaded not to go home until 11 years and stay in the solar yantra barge. In the wake of serious climate change, this energy storage yantra is designed with the purpose to create a public movement toward adoption of 100% solar energy. He has been honored with the brand ambassador of solar energy of Madhya Pradesh government. Professor Solanki has also been referred to as a solar man of India by Times of India, The Hindu, and India Today. Some people also call him Solar Gandhi. Professor Solanki has led major solar projects at IIT Bombay, Through his SOL project, he has reached 7.5 million families, providing them clean light. There are several awards to his credit. These awards include IEEE Global Grant Award worth $100,000, Prime Minister Innovation Award for the SOL project he led, first prize in Solar Chula Design Challenge by ONGC, 3 Guinness World Record, 2 Young Scientist Award, and excellent in RE scaling. He also the chairman of the committee of CBSE and AICTE for curriculum of solar syllabus and many more. Professor Solanki has written 7 books and published over 100 research papers internationally. He has 4 US patents to his credit. To establish energy storage globally, he has founded the ESF, or Energy Storage Foundation. During 2019, Professor Solanki traveled across the world covering 30 countries to spread the message of solar energy. In this ongoing energy storage yantra, he has already traveled 13,000 kilometers, reaching over 25,000 people across 5 Indian states. The 11-year yantra is expected to cover about 200,000 kilometers across 28 Indian states. The yantra aims to bring awareness to more than 100 courses on energy and climate change through energy literacy and encourage more than 1 crore families to gain energy independence by 100% generating and consuming energy locally without any grid connection. Let us please welcome Professor Solanki for his keynote talk. The floor is yours, Professor Solanki.
Thank you so much, Dr. Kong, for very kindly introducing me. It is my pleasure to be here among all, and I'm going to talk to you about energy, climate change, and what we as an individual can play a role. I hope I'm audible. You're able to hear me?
Yes, Prof. Everything's good.
Am I audible?
Yes. Please, Prof. Everything is okay. We can see your share screen now.
Am I audible, and can you see my screen?
Yes.
Okay, great. So, as suggested, I'm going to talk to you about climate change and energy storage and how each one of us are playing a role in it. And to begin with, let me put a point forward. So, by the way, I'm going to bring out the technical angle, the philosophical angle, the scientific angle to the climate change problem and how we can solve it. So, to begin with, let us realize that we are the modern humans of 21st centuries, and we are very advanced species existed on this planet. We are scientifically advanced, technologically advanced, economically advanced. And when we are so advanced, one of the Greek philosophers, the Plato, mentioned in his book, The Republic, he said, king should become a philosopher, or that philosopher should become king. So with all the science and technology we have, we are also very powerful. And when we are powerful, it is important that we are philosophical. And without the philosophy, the humans are like headless chickens. And I feel that the modern humans of today are like headless chicken, and we are just growing and growing and growing, really without knowing where to grow, how much to grow. And that is the problem of this world. So my first philosophical question to everyone is, how are you? And everybody says, fine. Nobody says that I'm happy. So when we are so much of advancement in terms of science, technology, comfort, money, everything, isn't everybody should be happy? that is not the case. And for example, everywhere the GDP is increasing. I can take example of India. For last 20 years, GDP is increasing. But my basic question and fundamental question is, every time when GDP increases, does it result in increase in smile also? Probably not. In fact, as the societies are becoming modern, advanced, there is a more stress, there is a more violence, there is a depression, and therefore I believe that there is something wrong in this world. How can we increase our science, technology, economy, but at the same time, affect our own health and mental and physical health? My second philosophical question to everyone is, what is the most important thing in your life? The most important thing. And people would say parents, children, job, money, position, health. These are all important parameters, but we all forget that the most important parameter is not all this. It is the air. We cannot live without air for more than a minute. We can't breathe without an air. So therefore, air is very important for our life. So important that we cannot survive without it more than a minute. If that is the case, are we all doing something to protect the air? Probably not. Are we doing something to pollute the air? Answer is yes. Air is getting polluted in many cities, and in many cities of India are like that. I'm sure many cities of China are like that. Many places all over the world. So GDP is increasing, but air is getting polluted, water is getting polluted, soil is getting polluted because of so much of chemicals we are pouring. So GDP is increasing, but nature is degrading. So it looks like there is something wrong in this world. How can we increase GDP but degrade the nature, which is the very base of our life? We cannot survive on the planet without the nature. How can we degrade the nature is a big question. So I feel that there is something wrong in this world. Air, water, soil, forest, river, everything is in a bad shape. Air quality index, for example, should be less than 50. But in many parts of the world, the air quality index is 150, 200, 300. Water, forest is important for us. Forest is considered the lungs of the planet. But more than 30% of the forest have been cut down, 30%. That is really not good for the humans. Water is important, and we are very modern human species of all the time. But 500 million people in the world suffer from severe water scarcity throughout the year. What does it show? That there is something wrong in this world. Soil, we have been putting so much chemicals that 33% of the earth soil has been degraded. And it is estimated that by almost 90% could degrade by 2050. So basically, things are not normal in this world. And the question is, what has driven us to this state? Why? What has driven us to this state? And the answer is, it is the use of energy. We have been using energy in a really big way. So it is the energy that is driving us to this state. And the whole world is a play of energy. There's internal energy, external energy. And whenever our energy levels are down, or whenever we are not using right energy, we suffer. And the external energy that is driving our vehicles, our computers, our laptops, our lights and fans, that energy is also not good. But energy is important. Everywhere in this world, all the development parameters, social parameters, economic parameters, the important factors are all energy related. Whether it is power, hunger, health, education, gender, climate change, even global peace and partnership has a relationship with energy. So energy is very important. Everything is energy, and energy is everything. The problem of this world today is, ever since we are industrializing ourselves, we started industrialization in 1850s, then 1900 we started using coal and oil. By 1950 we started using coal, oil and gas. Today look at beyond 1950, how fast our energy consumption has increased. We are using coal, oil, gas, wind, solar, biomass, nuclear, everything. But the problem is that 85%, 80 to 85% of world energy requirements are fulfilled using three sources: coal, oil, and gas. All of us are using in a big way. And if that is the case, whenever we use these carbon-based fuels, we are responsible for this equation. Carbon plus oxygen results in energy plus carbon dioxide. So we are emitting carbon dioxide every time when we are cooking food in the kitchen, we are using electricity, we are using petrol and diesel. We are all responsible for carbon dioxide emission, rich and poor equally. And this carbon dioxide is a garbage of the atmosphere. We do not realize this, but we are throwing garbage in the atmosphere all the time. And this garbage is not a simple garbage. This is a greenhouse gas. And therefore, this carbon dioxide is going to have an impact. The amount of greenhouse gases that we throw in the atmosphere in terms of weight is 10 times more than the kitchen waste that we throw in the atmosphere. 10 times more. As a result of that, the carbon dioxide is accumulating and accumulating and accumulating. There is right now, this is a graph of 1,000 years, especially in last 150 years. Look at how much accumulation of carbon dioxide in the atmosphere has happened. And this carbon dioxide, by the way, once emitted, remains there for 300 years. And as a result of that, the carbon dioxide emission is increasing, the global temperatures are rising. And as per the current estimate, the global temperatures are above 1.1 degrees centigrade as compared to pre-industrial era, which is equal to 2 degrees Fahrenheit almost. And I keep giving example, our body temperature is typically 97, 98 degrees Fahrenheit. When the body temperature increases by 2 degrees, we have got the fever. Similar to that, the planet has got its temperature increased by 2 degrees Fahrenheit, and we can say that planet has got fever. Oh my God. When we get fever, we lose balance. We can't eat properly, we can't work properly, we can't sleep properly. Similar to that, planet has also lost its balance and it cannot work properly anymore. There are floods everywhere. This is an example from China, but not only that, there is a floods in Japan, floods in Indonesia, in Australia, in Europe, in America, in Brazil, Africa, India, everywhere there are floods and floods. Even there were floods in the Saudi Arabia, the desert country. There are forest fires everywhere, Australian forest fire, Amazon, Greece, Italy, Turkey, Russia. The sea ice is melting from North Pole and South Pole, so much so that almost 30 to 40% of ice has been melted from the North Pole. This is going into the sea and sea level is rising. This is image of Indonesia's capital, Jakarta. It looks like it is going to sink anytime now, isn't it? It is also referred as world's fastest sinking city. There are heat waves everywhere. In one of the cities in Canada, the global temperature has gone up to 49.6 degrees centigrade. So there are more cyclones, there are more typhoons, there are more problems everywhere in this world. Why? Because the global temperature has increased by 1.1 degrees centigrade and the planet has lost its balance. The climate scientist tells us that we need to limit the global warming to 1.5 degrees centigrade, ideally, if not 2 degrees centigrade. Maximum we can afford to go to 2 degrees centigrade. Why? Because beyond this point, beyond 1.5 degrees centigrade, the climate change will start to become irreversible. Irreversible, which means what? We cannot correct the climate change once we cross this limit. How much time is left before we reach 1.5 degrees centigrade is another important thing. As for the remaining carbon budget, we have about 270 billion tons of carbon dioxide we can emit for 1.5 degrees centigrade and 2 degrees centigrade, 1,050 billion tons. But the surprising part is the rate at which we are emitting. We are emitting at the rate of 1.3 million kilograms of carbon dioxide every single second. 1.3 million kilograms of carbon dioxide. So when we divide these two numbers, the time left as per the climate clock is very little, very short. 7 years, 7.5 years is the time left before we reach 1.5 degrees centigrade of global warming. And therefore, I believe 1.5 degrees centigrade is the most important number of every human being on this planet. 1.5 degrees centigrade. But the problem is that the modern humans are stuck in the contradictions of their own. One side we want growth, other side we want to limit the climate change. But growth requires energy, and because 85% of our energy comes from the fossil fuel, every time we grow, we are also growing climate change. So there are contradictory requirements. One side we want to grow energy supply, other side we need to decrease energy supply. This is a big problem for the entire world. And it is just not a problem of change of weather system. It is a problem of human existence, whether the human life can survive on this planet or not. And I keep saying that anybody who solves this problem should not get just one Nobel Prize. He or she should get many Nobel Prizes, because this is a threat to the human existence on this planet. So as per the IPCC, the Intergovernmental Panel on Climate Change, we need drastic and immediate changes in the energy use pattern. We need drastic change, not a small change. And we need immediate change. So drastic and immediate change in the energy use pattern is required. And I'm afraid that despite all the protocols, Kyoto Protocol, this, that, Paris Agreement, COP meetings, the reduction in CO2 emissions are not happening, rather it is increasing. So therefore, I believe that okay, shall I start? So what I believe that we need to drastically and immediately make a change in energy use pattern. And we need to switch 100% to solar energy. Anyway, the solar energy is the base of our existence. We cannot exist on this planet without the use of solar energy. And we have been, for thousands and thousands of years, we have been using solar energy. It is only that last 100 years, mainly, we started using fossil-based energy, and therefore we are suffering now of the climate change. So we need to go back to solar energy 100%. But even before we do this, there are some fundamental laws of human existence that we must. Laws of sustainability. This is based on father of India, Mahatma Gandhi. Mahatma Gandhi said, the world has enough for everyone's need, but not enough for everyone's greed. We can only satisfy our needs, not the greed. Why? Because the entire planet is constant body. It's a constant ecosystem of biological system. Water, air, soil, minerals, everything is finite on this planet. But modern human thinks that our production and consumption should continuously increase. That is fundamentally not possible. How can we continuously increase our production and consumption when we derive things from the planet which is fixed in its size? We can't. Therefore, the first law of existence is in an ecosystem of finite resources, there has to be finite consumption. We have to limit our consumption. And I believe no amount of science and technology can help us if we are not going to limit our consumption. No, we need to limit our consumption. That is the rule number one. Second thing, he said, not the mass production, we need production by masses. Because when we do the mass production, it results in unequal distribution. And growing inequity in the world is a very big problem. As the science is growing, technology is growing, economy is growing, there is a growth in the violence. There is no growth in the brotherhood. There is no growth in the love between people, but the violence is growing. So therefore, also there is something wrong. And therefore, the second fundamental law of existence is in an ecosystem of finite resources, there has to be distributed production. Our production has to be distributed in nature. So two fundamental things is limited consumption and localized production. This is really fundamental. Everything that we do on the planet, we have to follow these two laws. We cannot even violate one of them. And if you are going to violate any one of them, we are going to suffer. So therefore, limited consumption and localized production has to be the rule of the game. So if you want to food, limit your consumption and localize your production. If you want to drink water, limit your consumption, don't waste. And locally recharge your water supply. If you are wearing clothes, limit your consumption and localize your production. And if you are using energy, which we are all using it, you need to limit your consumption and localize your production. So what I'm saying is, the first rule is limit your energy consumption. And when we start doing it, is called energy Swaraj, energy independence. In fact, one of the big problem of this world is dependence of countries on other countries for energy. Because of this dependence, there is always tension. There are always geopolitical actions that are taking place. And these tensions sometimes create problems and creates war-like situation. So therefore, energy independence, energy Swaraj is one of the most powerful tool available today in the hands of people and the country. And fortunately, the renewable energy technology can help us to achieve that kind of energy independence. So I have created an approach, and it's a three-step approach that I have created for switching to solar energy. And if you're not going to follow this three-step approach, we will suffer further. So first step is avoid the use of energy by 1/3. Avoid the use of energy as much as possible, even if it is solar energy. Understand? Even if it is solar energy, even if it is renewable energy, even if it is free energy, the best thing is avoid the use. Why? Because even producing solar panels, you require a lot of energy. You need to make silicon, you need to make solar cell modules, you need to make glass, you need to make structure, electronics, batteries. So manufacturing of this requires energy. Recycling of these tools also going to require energy. And any manufacturing will have environmental side effect, and therefore the best thing is avoid the use of energy as much as possible. For example, in my house in Mumbai, in IIT Mumbai, we do not use any refrigerator, we do not use any geyser, we do not use any air conditioner. Why? Because we believe that avoiding use of energy is the best thing. Next thing is minimize the use of energy. If you cannot avoid, minimize by another 1/3. What does it mean? What does the minimization means? It means that what you need to do is use very efficient appliances. If you are using lighting, use efficient appliances. If you are using fan, use very efficient appliance. If you are using air conditioner, use very efficient. Every appliance today is available in a very efficient alternative. So use efficient appliance. And the last step should be generate only 1/3. First step is avoid. Second step is minimize. And the last step is generate. Where should we generate our energy needs? Locally, wherever we are doing it. And therefore, the rule is AMG. Follow this rule. A means avoid, M means minimize, and G means generate. How much? 1/3 energy needs should be avoided, 1/3 energy need should be minimized, and only 1/3 energy should be generated. And if you do not follow AMG, we have to say OMG, oh my God, solar energy is expensive. Oh my God, policies are not there, subsidies are not there. All kind of excuses will come. So let us follow AMG rule. And when we follow AMG rule and adopt to solar energy 100%, it becomes energy Swaraj, which means we should learn how to generate and fulfill our energy needs locally with the help of local resources and local people. Let localize our energy solution. So when in 2018-19, we have taken part in IEEE competition of empowering billion lives, and it was an international competition. There were 450 teams, and we bet all the teams, and we become the global winner of the competition, and we got $100,000 prize money. Using that prize money, I have donated and created a foundation called Energy Swaraj Foundation. And the purpose of Energy Swaraj Foundation is to establish Energy Swaraj everywhere in the world, energy independence everywhere in the world. I also believe that the government all over the world, when I traveled across the world, I realized that the government all over the world, whatever action they are taking is not sufficient. And it cannot be sufficient. Governments always are elected for short time, and therefore, instead of only focusing on policies and governments, we as an individual should start doing something. And therefore, I started my journey of 11 years. I have pledged that I will not go home for 11 years. I'm going to live in this bus for 11 years. I'm going to travel across the country, across the world to bring this message that the climate change has already become a severe, and all of us have contributed to the climate change because all of us are the user of energy, and therefore all of us must take steps to solve the problem of climate change. So not the government, it should become public movement. Public at large should take part in contributing into climate change. Public should come forward. Each one of us should do it, not for our country, not for the society, at least for the sake of our own children. We want our children to live on this planet. We want to leave them a planet where they can breathe, where they can drink clean water, where they can eat chemical-free food. We need this public movement. I want everybody to contribute in this, and therefore I believe that individuals and institutions can play a very important role. You and I as individuals can immediately decide to become energy independent. Institutions, academic institutions can play a very important role. In our institution, we can make independency and we can encourage our students to become energy independent proudly. By the way, there is an energy literacy training that I have formed, and I encourage everyone to become energy literate. It is the lack of energy literacy which is resulting in a climate change. We are not aware about how much energy we use, where the energy comes from, how much carbon dioxide we are emitting, what is the impact on the environment, how can I reduce my energy consumption, how can I go on solar. So all of you, I encourage to become energy literate by doing this training available for free at learn.energyswaraj.org. We also do not take any money from the government, but to create a public movement, we invite people to support us and become our member, so you can actually contribute and donate so that we can solve the problem of climate change and make the world better and beautiful place to live. We are also going to start the clubs, Energy Swaraj clubs, and you can actually start Energy Swaraj club in your area so that you can start taking action towards energy independence. So in the end, I would like to say that the climate is not changing, climate has changed. And who has changed the climate change? All of us. Every user of energy has contributed to the climate change, and therefore every user of energy must be the part of the solution. And if you do not do that, by the end of this century, the global temperature will rise to something between 3 degrees centigrade up to 6 degrees centigrade. End of century is only 78 years from now. And if we do not do this, when the global temperature will rise to 3 degrees, 6 degrees centigrade, there is a big question mark whether human life can survive on this planet or not. Human life, there's a question mark. It may be 80 years, it may be 100 years, it may be 150 years. So, like we say, that once upon a time, there were dinosaurs on this planet. They are not there anymore, they got extinct. And if we do not behave properly right now, maybe 3,000, 4,000, 5,000 years later, a new species will appear on the planet and they will say, once upon a time, there were humans on the planet. Oh my God. I hope before it becomes too late, all of us are going to take appropriate action and solve the problem of the climate change as we individual. So once again, thank you very much to the conference organizers. Thank you very much to Dr. Kong for inviting me and to share these ideas with everyone. And with that, thanks a lot, all the audiences, and I would be happy to take some questions. Thank you very much.
Thank you. Thank you, Professor Solanki. Thank you for the interesting talk. And I think we should appreciate the strong message that sent over from Professor Solanki. Let's appreciate whatever we have. It look like it is free, but it is invaluable. So now I'd like to open the Q&A session to the floor. So anyone that would like to raise any question to our keynote speaker, Professor Solanki, please walk up to the stage through the 2 staircase and stand on the speaker box, the light blue color box with the speaker icon. Then you can speak to the public and everyone can hear you. Please. Or if you have any question that you want to ask personally, then you're welcome to post it on the chat box or email, maybe.
Yeah. You can also put a message in the chat box, and
yeah,
I will type the email ID. So if you want to write to me directly, you can also.
Yeah.
So I have typed my personal email ID. Please do that if you want to become energy literate. I'm also typing the website again, learn.energyswaraj.org. You can do that.
Okay. So if no live question now, so
somebody is wanting to ask in the chat box.
Okay.
The chat box will be open. I think somebody wanted to ask.
No. I think no question.
Okay. No, just now many people. I mean, I saw that slide. Okay, no problem.
Okay. So thanks again, Professor Solanki, for your resourceful talk and the strong, important message. Now, we hope, we all can learn a lot from you. Okay, the enthusiasm you show, I think it sends us a strong message, and we should rethink something important in our life. Okay.
Yes,
there's so many things important other than our career. Okay, thank you. Thank you again. We hope to chat more to you. Okay, thank you. Bye. See you again. I hope I can meet you. Before you end your journey, this 11-year journey, I can meet you somewhere in some part of Indian state when I traveled to
Yes.
India after the pandemic. Okay, thank you. Thank
Yes.
you. Bye bye. See you again.
Bye.
So for the participant, okay. So we left with another keynote talk in the morning, tomorrow morning, from Professor Michael Leong from City University, Hong Kong. So for now, you can proceed to room A and room B for the oral presentation session. Okay, thank you. Thank you, ladies and gentlemen. Bye bye for today.